Hello and welcome to this brief overview of BOM to CAD with Variant Management Overview. It's going to be a quick presentation here, but just to give you the idea of what's going on with the ESSIG BOM to CAD development. So without further ado, I have an aircraft variant in Aris Innovator, and I want to be able to go and build an aircraft and push it into a CAD system. So we're going to use the variant management functionality in Aris Innovator. And we have some features such as the type of aircraft, the duty, the range, the ownership. I won't go too deep into a variant management example here, but when I get into my variants such as propulsion systems, airframes, landing gear, accessories, some of the things you'd want to know if you were going to build an aircraft, if it's a heavy duty, if it's a light duty, is it passenger, is it military, those types of things would affect the look and feel of the aircraft, and then the structure with the options, right? So I have features and options and variants in there. So what I'm going to do here is I'm going to go build an aircraft, and what I want is I'm going to build an aircraft, a passenger civil aircraft for the United Kingdom. So there's going to be a couple of questions there. Rather than do that, I already have the resolution kind of saved to kind of make this presentation move along, but I'm going to answer questions like what type of aircraft, what's the duty of it, what's the range, who's going to own it, what type of propulsion system, right? Is it going to be jet? Is it going to be propeller? Is it turboprop? Those types of things. And based on my rules, there's things I can select and not select, just like with typical variant management. So having done this already for the UK, I'm going to find this predefined one. So this is a UK passenger jet, custom defined airframe. If I go look at it, I can see it's a combustion power type. It's a jet. I'm not even allowed to pick these two, propeller or turboprop. So all of that stuff has been answered. So what I want to do now is go and resolve this. So when I hit the resolve, it's going to go look at the rules, obviously with standard out-of-the-box variant management. So building the features and the options and the variants, and then the rules, the usage cases for each of them, it's going to show me what the aircraft would look like. So for example, I'll expect to only see 2 engines and light landing gear, not heavy landing gear, not 4 engines. So I'm starting to see, what this is going to look like here. The next thing I would need to do, though, is what do I do with this? I want to turn this into a bill of material. So with the ESSIG sort of PLM to BOM, we're going to create a BOM from this variant management, which is a little different than effectivity. Effectivity, you start off with a 150% BOM, and you kind of whittle it down based on rules. With variant management, you actually have to build the BOM, right? You don't necessarily have the BOM at all. So that's what we're going to do here. And it's based on some rules. For this presentation, for example, you'll see the assets. If it's a part asset, we're going to incorporate that into the bill of material. The aircraft has no part number. It has no part. So we need to create that, and that's exactly what this is going to do. This is just going to use a simple sequence to create the part number. Obviously, we would work with the customer to say, how do you want to create your part numbers and all those types of things. I won't give it any suffix for this particular example. So what I'll expect to see is a top-level brand new part number with all of the subcomponents, such as the engines, the landing gear, some of the stuff that's repeatable, right? I use this over and over again for my deliveries of aircraft. We're not constantly literally reinventing the wheel. We have a lot of that technology already in our knowledge base here. So that's all been incorporated, and that's what you're seeing here. So we know how to build an engine, or we know who to buy it from. Here's the airframe, here's the main landing gear, but we want to roll this all up into this brand new assembly, the 161 here. We'll call it for the UK. Incidentally, if I briefly show you a little behind the scenes here, everything has a transformation matrix in here. So that's kind of, how does it know how to assemble it? Well, we have the ability to capture transformation matrices. There's other ways to do this as well. So for an engine inner left, you can imagine there's an engine inner right. There's an engine outer left, potentially an outer right. So we're using reference designators in this example. How do I place it relative to the fuselage and the wings? That's kind of baked into this already. So we don't have to, start from complete scratch and just get a bunch of parts delivered to us. We know how to assemble them to a certain degree. So we're going to go look at that. So what I'll do here is we'll close out of that, and we're going to say create BOM to CAD. So what's going to happen here, it's going to take this new assembly that we just created from a variant, and I'm going to say, now push this, what you have here, as best as you can into CAD and show me what we have. So that's exactly what it's going to do here. And you're going to see SolidWorks in this case open up. The connector is now kind of talking backward. We're used to the connector going, from CAD to ARIS. It can also retrieve, obviously, from ARIS to CAD, but in this case, we're going from the bill of material. There is no assembly, so we're going to create the assembly right within SolidWorks. We're going to assemble those components right within SolidWorks. So this is all for the very first time you're seeing that. Usually you start off with assembly that's already created. The engineers had to go create it, they put it in, then the system engineer looks at it. This is more of the reverse. The system engineer said, hey, I want to see this. I'm going to answer a few questions. Let's see what we got. How much knowledge do we have already within ARIS Innovator? Can we take this and push it back, and how close can we get before the engineer touches it? And to that point, I want to mention this is not to replace engineers, right? This is to get them a very, very big head start. They don't have to go and pull all of this stuff and recreate, the assembly. If it's already in there, if the rules are already in there, how we can do this, let's put those into ARIS and then have ARIS tell CAD, based on these rules, we want you to assemble it this way. So this will take about a minute to pull up the assembly. So here's the new 161. You're seeing that right here. It's putting it together now, and you should see a UK civil passenger jet show up here in a very short time. And the one thing that won't be placed right, most of this aircraft is put together right. The one thing by design for this presentation is the antenna. And I'll show you that here in a second. So there it is. Okay. So now this is so now the engineers can take this. I could be the engineer doing this and saying, oh, this is right, but wow, this antenna is way out of whack. So in this case, it didn't know where to put it. Some airlines might want to put it forward, some might want to put it aft. I won't bother assembling that now. But that's the type of thing we want to convey. It's not going to build everything for you necessarily. There's still engineering to be done. But it gets you certainly 99% down the road based on internal knowledge and things that you've done. So that's all I wanted to show for today. I'm sure there's some other questions, but thank you for your time, and I hope this was useful.